Algebra 2. Mr. Poley back here for yet another Algebra 2 lesson for you guys in our linear functions unit. Today we are moving on with linear modeling. So this will be on pages 89 and 90. You guys can thank me later. We skipped the forms of a line lesson on the couple previous pages. So we went from average rate of change, which was lesson number 2. And now we're on to linear modeling, which is lesson number 4. Boom. That's how that happened. That's how that works. Linear modeling, something we should be familiar with at this time from our study of Algebra 1. Okay, so this might be a little bit of a review, but it could also seem new to you, and that's okay. Okay, in Algebra 1, you use linear functions to model any process that had a constant rate at which one variable changed with respect to another. Okay, and that meant that that process had a constant slope. And we all know that linear functions are the only functions that always have a constant slope. That is a huge, important characteristic about linear functions. Their slope is always constant. That's why lines are perfectly straight. A line is not a line if it's not straight. And if it's not straight, that means it doesn't have a constant slope. So keep that in mind. We're working with linear models today. So everything in this lesson has a constant slope or a constant rate of change. Okay, that means one variable is changing at the same rate with respect to the other variable. Okay, dependent variable, independent variable. That dependent variable changes as the independent variable changes. Again, at a constant rate. All right, so let's get into it here. Dia, exercise 1. Dia or Dia was driving away from New York City at a constant speed of 58 miles per hour. So as always, I love to underline our key words. Dia was driving away from New York City, so getting farther from New York City. Moving at a constant speed. Okay, so that tells us right now that, even though I kind of already gave that away, we're working with a linear function here because it's a constant speed. And that constant speed is 58 miles per hour. So right away, we should hear that term constant speed, constant rate. And with the units that they give us there, that value, that is our slope. Okay, we need to hear constant speed or constant rate and think, boom, that's our slope. Okay, that's what gives this linear function its structure, is the ever-important slope. The last thing here, he started 45 miles away. His starting point was 45 miles already away from New York City. So where he starts, again, something we need to remember or bring back from Algebra 1, that starting point is our y-intercept. Okay? In a linear function, in a linear model, there's almost always a slope and a y-intercept. Those are the two important factors, the two important components of a linear model or a linear function. And that's good to know because we're about to create this linear function in letter A here. It says, write a linear function that gives Dia's distance d from New York City as a function of the number of hours h that he has been driving. So I hope this is a time where you guys remember things that I've said before. Whatever thing is a function of the other thing, that is our dependent variable. The dependent variable is a function of the independent variable. So distance d is a function of the number of hours h that he has been driving. So we want to come up with something of this form, y equals mx plus b Again, I know that just rolls right out of everybody's head, right off your tongues. Y equals mx plus b. Form of a line. Slope-intercept form. It's called the slope-intercept form because in order to write this equation or this function, we need those two things. M is our slope, and B is our y-intercept. Nice job, guys. Okay, slope-intercept form. We need those two things. But since they give us, and this is important moving forward always in math, we have to use, if they give us specific variables, we have to use those. We need to. No question about it. So the distance D, like we already said, is our dependent variable. So that takes the place of y. And the number of hours, h, is our independent variable. So that takes the place of x. Okay, so one step at a time here, we're trying to come up with this function, this model, to model Daya's driving from New York City. So we have D equals MH plus B. Now we just need to fill in again what I said before. We need to fill in M and B. So what's our slope? Go ahead and read that first introduction sentence there. Okay, just like English class, we got an introduction, we got a body here, and we got an end, a conclusion. So read that intro, figure out what our slope is. Oh, lucky for us, we already labeled it. What's our slope? That's right, it's 58. So D equals 58H plus B, which is our y-intercept, which is where Daya started from. That was 45. So D equals 58H plus 45 is a perfect model, perfect linear function that models this scenario here. Okay, this shows on that for every hour that he is driving, he gains 58 miles from his already 45 miles away. So he starts 45 miles away and increases that by 58 miles with every hour that passes. And again, guys, time waits for no one. Don't forget that. So now over in B, our conclusion here. If Daya's destination is 270 miles away from New York City, algebraically determine to the nearest tenth of an hour how long it will take Daya to reach his destination. So algebraically determine is a key there. We can't just use our calculators. We have to do this algebraically. In the nearest tenth of an hour, how long it will take Daya to reach his destination. So his destination is 270 miles from New York City. And that distance D, or D was the distance, is the distance from New York City. So here they're telling us that D equals 270. Again, that's the distance Daya will be or is from New York City. So his destination, 270 miles from New York City. We need to figure out the number of hours, the H value that will make D equal 270. So we came up with this function. Here, guys. It makes sense that we are now going to use it. We're going to apply this function. So I'm just going to rewrite it here. D equals 58H plus 45. But I know that I want D to equal 270. So that takes the place of D. So we have our function value. We need to find our H. How many hours does it take Daya to be 270 miles from New York City? Okay, and equations like this now, we've had much practice with these. We want to subtract 45 from each side. I'm going to continue this up here. We get 225 equals 58H. And that last step, divide by the coefficient to get our answer to the nearest tenth of an hour. 3.9 hours. That is how long it will take Dia to reach his destination, which is 270 miles away from New York City. Okay? We took a situation here, created a linear function to model it, and use our model to apply it and answer a question that could have happened in real life. Okay? So that's just our first glimpse back into linear modeling. All right? So we're going to go on to the back of the page now. We're not doing exercise number 2. We're going to skip right over that. All righty. Okay, this is where you will absolutely need your calculators. So if they're not out already, get them out, get them in your hand. Well, if you're right-handed, get the calculator in your left hand so you can still take some notes here, okay? So I'll read what it says at the top. Many times linear models have been constructed, and we are asked only to work with these models. Models in the real world can be messy, and it is often convenient to use our graphing calculators to plot and investigate their behavior. Okay, so we can come up with models, sure, like we just did on the front, but a lot of times, like this exercise here, the model is a little too messy to really work with too much by hand or on our own without the help of this handy dandy tool. So this is what we're going to use here. Okay, let's read what this is all about though, because that would help. A factory produces widgets, which are generic objects of no particular use. Okay, a widget, it's like, what is it? It's a widget. What does it do? It does widget things, okay? So the cost, C, in dollars to produce W widgets is given by the equation C equals 0.18 W plus 20.64. Okay? Each widget sells for 26 cents. Thus, the revenue gained, R, from selling these widgets is given by R equals 0.26 W. Okay? So in both of these models here, this cost function and this revenue function, I'm going to write this little note here. Both cost and revenue depend on the widgets. Okay? Don't write too much into this graph because we're going to sketch something here. Okay, the cost given by this function here, the cost depends on how many widgets are produced, and then the revenue here depends on how many widgets are sold. Okay, the cost depends on how many widgets are produced. The revenue depends on how many widgets are sold. Okay, but both of those things depend on the widgets. So widgets are definitely our independent X variable, which is going to go across the bottom here. Okay, so now that we've got an understanding of what is going on here, let's figure out what we have to do. Use your graphing calculator to sketch and label each of these linear functions for the interval 0 to 500. And that is a domain interval. Notice that that's in terms of the widgets. So we're going to graph and label each of these from 0 to 500 widgets. So we're going to look at how the cost changes in terms of those widgets and how the revenue changes in terms of those widgets. Guys, if you have never said the word widget, say that now, please. It's kind of fun. Widget. You're going to get hooked on it. Be sure to label your y-axis with its scale. Okay, so how should we go about this? Well, first, again, if you don't have your calculator, grab that now. We're going to go into y equals. Brings up this window here. Okay, y equals. I'm going to put my cost function in. So I'm typing 0.18x plus 20.64. And And then I'm also going to put in my revenue function right away. So there's my cost, 0.26x. Okay, we can't use W for widgets on here, so we're going to use X just like we normally would. All right, there's my cost function in Y1, my revenue function in Y2. All right. So since they tell us the interval, the domain interval that we're going to be sketching this in, we need to figure out what is the Y interval, what's our range interval? How do I scale this out? Okay, so let's figure that out. So we are going to press second window, before even going to the graph, brings up this table setup screen. Okay, I'm going to tell my table right now to start at 500 because that's an X value. That's a domain value that we're starting at. Okay, your table does things in terms of the X's. So I'm saying to start at 500 since I know that's the last domain value that I am going to include in my graph. So if I put 500 in here and then go to my table, this will show me how large I need to make the scale for my Y. So if you guys can see, at least on your calculator, you'll see that the largest Y value for an X value of 500 is 130. So this needs to get up to 130. I'm going to put 130 there. And I'm going to try to go by tens just to get we're not going to do anything super precisely on here, but just to get an idea. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Boom. Almost perfect there. Okay, going up by tens. 10, 20, 30, all the way up to 130. Because that is our maximum Y value. Okay. So now based on our Y equals page, I know that my cost function will be blue and my revenue function will be red. Oh, but I almost skipped a step. Oh, right. So we know from this interval here, 0 to 500, that our minimum X is 0 and our max X is 500. Okay, and now based on what I saw from my table, and when we looked here to get that maximum function value of 130, and based on how this window is given to us, I know my minimum Y value is also going to be 0, but my maximum Y value is that 130. So I'm going to use these minimum and maximums here to set my window so that what I'm looking at on my calculator is the same as what I want to show on here. And to do that now, you press window. Not second window, just window. Okay, and that brings up your X min, X max, Y min, Y max. So you want to type in 0 for your X min, 500 for your X max, 0 for your Y min, and 130 for your Y max. And then press graph. I don't know if anybody saw this on mine before, but I had that function entered wrong. I had 0.08 for cost, but it's 0.18. So please make sure your functions are correct on your calculator. All right. And then we can press graph. Try to get not a glare here. Okay, again, blue is our cost function. Red is our revenue. So I'm going to just create a rough sketch of those. You can see the revenue starts at the origin because the y-intercept there is 0. Starting at the origin, and this one is going to go all the way up to y equals 130 here. Okay, I'm going to label this. This is my r equals 0.26w. Okay, now I need to get my cost function, which the y-intercept was right around 20. So that means it's starting right around 20 here on the y-axis. It's going to go up. Oops, let's redo that. And guys, you should be using your straight edge here. We're going to go up. It intersects at some point, then continues over. All right, and this I'm going to label C equals 0.18W plus 20.64. All right, so I have my revenue function here labeled right under it. And I have my cost function here, again, labeled right under it. Okay, so that is our sketch. And we labeled each of our linear functions over this interval from 0 to 500. Maybe let's just label 500 here too. Okay. So letter B, use your calculator's intersect command to determine the number of widgets that must be produced to equal the cost, for the revenue to equal the cost. So our intersect command, we can see on our sketch here, we're looking for that point. Okay, that is the point where the revenue equals the cost. Cost function equals the revenue function at this point. So we want to press second trace, which brings up the calculate menu. And then we press 5 for intersect, which that should bring you back to the graph. It's asking first curve, you can press enter. Second curve, again, press enter. And then it says guess. So you just want to move that cursor as close as you can to that point of intersection. And then again, press enter. And then you'll see on the bottom here, gives you your X and your Y value for that point of intersection. But if we're wondering what's the number of widgets that must be produced for the revenue to equal the cost, are we looking for the X or the Y value? We're trying to determine the number of widgets. Okay, remember widgets are our independent variable because the cost and revenue depends on the widgets. So we're focused on the X value here. And that X value is 258. I'm just going to label that point 258, 67.08. And it's that 258 that we want. Okay, it takes 258 widgets for the cost to equal the revenue. Moving right along here, taking this a little further as far as companies are concerned. Okay, now we're talking about profit. We looked at cost, we looked at revenue. Now we're talking about profit. And profit is defined as the revenue minus the cost. That's true for any company in any situation. That's how profit is calculated. Take your revenue and subtract your cost. The money you earn from selling things, and you subtract the money you had to pay to produce those things. Okay, so profit defined as revenue minus cost, and they're telling us profit is P. We need to create an equation in terms of W. So my profit is equal to R minus C, revenue minus cost. So to set this up, I'm going to take my revenue function, which is 0.26W, and I'm going to subtract, I'm going to put this in parentheses, my cost function, which is 0.18W plus 20.64. All right, we subtract these things now. 0.26W minus 0.18W is 0.08W. And we don't have anything here, so that's 0 minus 20.64 is minus 20.64. So that is our equation to model the profit. P, profit, equals 0.08W minus 20.64. Okay? So this means right off the bat with this equation, our profit starts in the negatives. Okay? And really needs a lot of widgets to get that profit to be profitable, right? To be greater than zero. To earn a profit, you need a lot of widgets to offset that negative starting cost. Okay, that's what this equation is showing us here. So let's move right down. Almost done here. Last part. This is the ultimate conclusion. Using your graphing calculator. Okay? Again, we need these handy dandy tools. Using your graphing calculator, sketch a graph of the profit over the interval 0 to 1,000. Again, our domain interval in terms of the widgets, we're going from 0 to 1,000. So right away, I'm going to label 1,000 on the end over here. And again, we need to use those tricks on our calculator to set our window so that we can see on our calculator what we want to have what sketch we want to have on here. Okay, so again, we're going to go to, let's see. We're going to go into y equals to enter our profit function, 0.08x. That's where I got the 0.08 from before. 0.08x minus 20.64. Okay, that's the only thing we want in our y equals now. Because we used our cost and revenue to get our profit. So we're only worried about profit now. We want to make that money. Okay, so that's in our y equals. We're going to go back to our table set by pressing second window. And let's see. I'm going to first start my table at 0. And here we know our minimum x is 0. Our maximum x is 1,000. Okay, that came right from this interval here. So I'm going to start my table at 0 because that corresponds to our minimum x. So I want to know when x is at 0, what is my y value? And that gives me a minimum y value of negative 20.64. Okay, so our y-intercept matches that. So when x is 0, this is our y value. Then we go back, second window, to look at that table setup again. I'm going to change the starting point to 1,000 now so I can see what the function is doing on the other end of that interval. Okay, and then second table shows us that our y value needs to get up to 59. So my max y is 59.36. So I'm going to round these when we set our window. Okay? So after figuring out those, a minimum, maximum, x's, and y's, we can go back into our window to set up our window, what we want to view on our graph. So again, x min is 0, x max is now 1,000, y min, negative 20.64, so I'll say negative 21 to make sure that we include that value. And then my y max, I'm going to say, is 60. Okay. Now we can press graph. And you should have something like that. Okay, which I think quite nicely now, you can see that looks more like the window we have here. Okay, so let's see. We're going to start down here. And this, again, just a rough sketch. There's no need to be exact. We're going to say this is negative 21. This top on the y-axis is 60. So we go from here through the x-axis. Try to make this as straight as you can. All right, so something like that. Now I'm going to label this again. P equals 0.08 W minus 20.64. And they do also tell us to label our x and y intercepts. So there, where our line, where our function hits the x-axis, that is our x-intercept. And down here, where we started, that is our y-intercept. Okay, almost done here. We got our sketch. One last question. What is the minimum number of widgets that must be sold in order for the profit to reach at least $40? Okay, and illustrate this on your graph. So what is the minimum number of widgets that must be sold in order for the profit to reach at least $40? So if we're talking about minimum and at least, we're going to use an inequality. And we want our profit to be at least $40. So that profit, $40, needs to be less than or equal to the actual profit that is made. So let's see, we're working with this profit function, P equals 0.08 W minus 20.64. But I want my profit to be at least $40, so I'll substitute in 40 for P, and that needs to be the lowest amount. We want our profit to be more than that. So $40 is less than or equal to 0.08 W minus 20.64. And now I can solve this inequality just like I would solve an equation to figure out how many widgets would give us at least $40. Okay, so I'll add 20.64. We get 60.64 is less than or equal to 0.08 W. Now the last thing would be to divide by 0.08 on both sides, and we get 758 is less than or equal to W. So we can turn that around. I like to write my variable on the left. So the widgets are greater than or equal to 758. So if the widgets are equal to 758, that would be the minimum number of widgets. This is saying the widgets have to be at least 758 or more. 758 or more widgets will get the profit to be at least $40. Okay, so when W is 758, P equals 40. So we can write that as a point. 758 comma 40. Right? Because the widgets, W's, our X variable, are independent, and P, profit, is our dependent. So X, Y, W, P. 758, 40. And they tell us to illustrate this on our graph. So we want to label that point somewhere on our graph. So if we're already on the graph, press second trace, which again brings up the calculate, and press enter on value. We want to find a specific value. And you should see your cursor flashing, blinking on the bottom here, says X equals. Well, we know now based on the work we just did that we want X to be 758. So type that in, press enter, and it should show you the specific point where X is 758, and just like we found out, just like we calculated on our own, X is 758, Y is 40. So that's somewhere right around there. Okay. So again, 758 is the minimum number of widgets for the profit to be at least $40. That is that point right there on this function. That's what that represents. All right. Whew. All right, guys. Take a breather here. Shake out those hands. Shake out those fingers from using the calculator so much. Ooh. Hope you guys stuck with me here. This was an important lesson, just kind of just reminding ourselves how to use the calculator, some very important features of the calculator, the intersect command, the value command, setting the windows. Those are important things that we will need to do more throughout the year. So please take the time to remind yourself how to do these. Rewind in the video if you need to and rewatch some things. But I'll leave that to you guys. You guys know what to do. You guys know what's expected. So thank you. Thanks for being here. Thanks for following along. See you guys in class.